Hello, my name is Andrew Norris, and I'm going to talk about the effort shown on this slide here, which is a combined effort of Rutgers University, Missouri, and the University of Texas at Austin. The common theme is non-reciprocity, so I'll talk about non-reciprocity in mechanical systems, starting with an example of reciprocity, where we have a linear system of masses and springs. If we introduce a bilinear spring, which is a special kind of nonlinear spring, it only differs in its compressive versus tensile stiffness. Otherwise, it maintains linearity. The output is proportional to the input. And we can see that the reciprocity is broken here by this bilinear spring. Reciprocity is also broken in the dynamic sense if we have a section of bilinear springs and masses in between two linear sections in a chain of springs and masses. In this case, a wave from the left versus a wave from the right. Note that the amplitude of the transmitted wave is proportional to the input, but that the form of the output wave is unchanged. Another way to demonstrate mechanical reciprocity is by spatiotemporal modulation. In this case, a system inspired by the water wheel. It's a tube with grooves that are helical, and when the tube is rotated, it introduces a spatiotemporal modulation. This is the setup here showing the tube, microphone, and measurement system. Here we have the tube rotating with a wave incident from the left versus a wave incident from the right. In one case.
Hi, my name is Elliot Kang. I'm a recent graduate in mechanical engineering, and I've been assisting Professor Norris and Matthew Kelsten in their research on non-reciprocal acoustics for the past several months now. I have been involved in the current design you see here from the start all the way to where we are now in the testing phase. In the initial stages, I used Autodesk Inventor CAD software to conceptualize various 3D models in which one design was eventually selected for manufacturing. Due to COVID-19, manufacturing proved to be much more difficult since we are not given full access to the facilities Rutgers provides, so we had to get a little more creative using production methods like additive manufacturing and woodworking. For me, both of these methods were new, and I had to learn how to make a compatible design as well as the manufacturing process itself. Fortunately, Rutgers provides students with training workshops where I learned how to use the woodshop tools and the ShopBot CNC router for cutting the design's support frames. Most of the components were produced in-house with a 3D printer or at the woodshop, and it was a challenge to overcome limitations such as material restrictions and higher tolerances that are associated with using these, which some professional engineers in the field might experience. Currently, we're in the process of testing the acoustics of our newly completed piston system, which is automated through MATLAB programming, in which we may produce results parallel with simulated non-reciprocal behavior.